What's going on? I'm Zach and welcome to 5-Star Prep. In today's video, we're going to be checking out the 2022 AP Statistics FRQ number 1. And this problem right here, I classify as a total gift. That's right. You probably don't even have to be enrolled in an AP Stats class to understand it. So let's check it out. Taking a look at question 1 here, it says a biologist gathered data on the length in millimeters and the mass in grams for 11 bullfrogs. The data are shown in plot 1. A says, based on the scatter plot, describe the relationship between mass and length in context. And whenever we're looking at a scatter plot, we're always thinking about three things, describing them as strength, direction, and form. What is the strength, direction, and form of the scatter plot? Well, looking at it, let's just draw a imaginary line of best fit and see what it would look like. Something like that, right? Taking a look at all the points on our scatter plot, they're pretty close to that line that I just drew. And that line has a positive slope. So I'm utilizing all of this information to determine the strength, direction, and form. And as a result, I would say there appears to be a strong, positive, linear association between the length in millimeters and mass in grams of bullfrogs. And here that would make sense. Again, as any animal, it doesn't matter what it is, a frog, a human, an elephant, grows, in all likelihood their mass is also going to increase. So this all checks out, we're good to go. Let's move on to part B. Here it says, from the data, the biologist calculated the least squares regression line for predicting mass from length. The least squares regression line is shown in plot 2. B says, identify and interpret the slope of the least squares regression line in context. We've been talking about slope since elementary school. So go back to your 4th grade class and ask your teacher, hey, Miss such and such, or Mr. so-and-so, what is the slope of the line and what does it mean? Here they give you the slope of the least squares regression line in the equation. It is just 6.086 right here. Now we just want to say what that represents. Well, here the slope of any line is the change in y for a 1 unit change in x. So as a result, our slope is going to be 6.086. And interpreting that, we would say we expect the mass in grams of a bullfrog to increase by 6.086 grams when the bullfrog grows by 1 millimeter. And that's it. Again, it doesn't matter what your question is stating, we just have to change the context of our answer. Here, it's always going to be the change in y for a 1 unit change in x. So here we expect our y variable, our mass, to increase by 6.086 grams for every 1 unit increase in our x variable, or an increase of 1 millimeter. That's B. C, interpret the coefficient of determination of the least squares regression line, r squared, equals 0.819 in context. Now, I don't love this question because this is something that we're never asked to calculate in AP Statistics. Therefore, all we have to do is memorize a script, and if you know the script, then you're going to get the answer right. Here, r squared is a measurement of the variation in your y values. And in this case, we would say that about 81.9%, we want to convert this into a percentage, so we're taking the decimal and multiplying it by 100. About 81.9% of the variation in y, or of the variation in mass, is accounted for by the least squares regression line, LSRL, relating mass, your y variable, to your x variable length in millimeters. So here, again, it's just a script. It's talking about the variation in your y variables. Basically, the larger your correlation coefficient is, the stronger your relationship is between your x and y variables, the larger your r squared is. Because r squared is just taking your correlation coefficient and squaring it. So here, the closer the plots are, or the points are, to your line of best fit, the larger your r squared is, and that's what we're taking a look at here. D. From plot 2, consider the residuals of the 11 bullfrogs. I says, based on the plot, approximately what is the length and mass of the bullfrog with the largest absolute value residual? Well, going back to our scatter plot, here they're just saying which plot or which point on your scatter plot is farthest from the least squares regression line. And looking at our data, it appears it is this point right here. It's just farthest away from the line. That's it. That is all. Here we just want to say what that point is. So here, to identify it, I would just say what its x value is and its y value. In this case, its x value is going to be, give or take, 162 millimeters. And its y value, just going across, is going to be just above 350 grams, maybe 355. So here, I would just identify it as the point on the scatter plot with a length of about 162 millimeters and 355 grams. And that is all they're looking for there. Now we're going to go one step further in the final portion of this problem, and it says, does the least squares regression line overestimate or underestimate the mass of the bullfrog identified in part DI? Explain your answer. Well, here, if we just look at this point, the one that we just utilized in order to find the largest residual, here we want to determine if the least squares regression line is an overestimate or an underestimate. Look at the point. Is the point above your line or below your line? Here, your line is above the point. Therefore, your line is going to overestimate the mass. So here, it's an overestimate. And here, you probably could just say, it is an overestimate because the LSRL is above the point on the scatter plot. Now that would be like the basic answer. I don't know if you get full credit for that. What I would say is I'd bring in the residual. I would mention the residual here. Remember, your residual is going to equal your observed value minus your expected value. And in this particular case, your observed value is going to be lower than your expected value. Therefore, we're going to get a residual that is negative. And I am 100% certain that if you mentioned that it would be a negative residual, and therefore the line of best fit is an overestimate of the mass of the bullfrog, you would get 100% credit for that. So again, here you had to bring in to play a formula that you may not be familiar with. At least you should be familiar with it. It's just not on the formula sheet. But if you mentioned that, you would definitely get full credit. So that wraps up question 1 there. I hope that helped, and I'll see you in the next one.